Hi everyone, you're with me Andrew. I quite understand what I will tell you in a moment. I hope that what I will convey is useful for all of us. So please keep listening well, okay? This time we will discuss white blood cells a little more deeply. Are you ready? Yes, I think you're ready to hear it. Okay, now, let's start learning about the white blood cells in our body.
There is always a bright side behind the darkness. So let's start from here.
The immune system cells, often known as white blood cells, are the subject of this article. White blood cells is the album by the band The White Stripes. White blood cells, also known as leukocytes or leukocytes, are immune system cells that help to protect the body against infectious disease and foreign intruders. All white blood cells are created and derived from hematopoietic stem cells, which are multipotent cells in the bone marrow. Leukocytes can be found in all parts of the body, including the bloodstream and lymphatic system. White blood cells have nuclei, which separates them from other blood cells such as RBCs and platelets, which lack nuclei. Cell lineage is used to classify distinct types of white blood cells: myeloid cells or lymphoid cells, neutrophils, eosinophils, mast cells, basophils, and monocytes are myeloid cells. Myelocytes, dendritic cells, and macrophages are two subtypes of monocytes. Phagocytic cells include monocytes and neutrophils. T cells subdivided into helper T cells, memory T cells, and cytotoxic T cells. B cells subdivided into plasma cells and memory B cells, and natural killer cells are lymphoid cells. Lymphocytes. White blood cells were once classified based on their physical properties, granulocytes and agranulocytes, but this approach is no longer widely used. The white blood cell count is an important subset of the complete blood count because the quantity of leukocytes in the blood is typically a sign of disease. In a healthy adult, white blood cells make up about 1% of total blood volume, which is significantly less than red blood cells, which make up 40% to 45% of total blood volume. This 1% of blood, however, has a significant impact on health because immunity is dependent on it. Leukocytosis is defined as an increase in the number of leukocytes above the maximum limit. When it occurs as part of a healthy immunological response, which occurs frequently, it is considered normal. When it is malignant or autoimmune in nature, it can be aberrant. Leukopenia is defined as a drop in white blood cell count below the lower limit. This is a sign of a compromised immune system. The physical appearance of a blood sample after centrifugation gives rise to the term white blood cell. The buffy coat, a thin, generally white layer of nucleated cells between the sedimented red blood cells and the blood plasma, contains white cells. The scientific word for this type of cell is leukocyte. It comes from the Greek origins leuk, which means white, and cyte, which means cell. Because neutrophils produce the heme-containing enzyme myeloperoxidase, the buffy coat can turn green when there are a lot of them in the sample. The nucleation of white blood cells separates them from anucleated red blood cells and platelets. Leukocytes can be categorized in a variety of ways. They are divided into two groups based on their structure: granulocytes versus agranulocytes, and cell lineage: myeloid cells or lymphoid cells. Neutrophils, eosinophils, basophils, lymphocytes, and monocytes are the five primary types of neutrophils, eosinophils, basophils, lymphocytes, and monocytes. The physical and functional properties of these categories identify them. Phagocytic cells include monocytes and neutrophils. Subtypes can be classified further. Granulocytes and agranulocytes are characterized by their nuclei lobed versus round, polymorphonuclear versus mononuclear, and cytoplasm granules present or absent, or more precisely, visible on light microscopy or not thus visible. The other division is by hematopoietic lineage, which distinguishes myeloid cells, neutrophils, monocytes, eosinophils, and basophils from lymphoid cells, lymphocytes. Cellular differentiation lineage. T cells, B cells, and natural killer cells are all types of lymphocytes. Neutrophil. Neutrophils are the most common white blood cell. accounting for 60–70% of all leukocytes in circulation. They protect you from bacterial and fungal infections. They are often the first to respond to microbial infection, and their activity and death in high numbers produce pus. Polymorphonuclear PM leukocytes are the most frequent name for them. However, technically, PM applies to all granulocytes. They feature a multi-lobed nucleus with 3 to 5 lobes that are joined by short strands. The neutrophils appear to have numerous nuclei as a result of this, hence the name polymorphonuclear leukocyte. The cytoplasm may appear transparent due to tiny granules that stain pale purple. Neutrophils are bacteria phagocytosing cells that can be found in huge numbers in wound pus. After phagocytosing a few infections, these cells are unable to regenerate their lysosomes, which are required to digest bacteria and die in the early phases of acute inflammation. Neutrophils are the most frequent cell type. The typical lifespan of inactivated human neutrophils in circulation has been estimated to be between 5 and 135 hours using various methods. Eosinophil. In circulating blood, eosinophils make up roughly 2–4% of white blood cells. During the day, seasonally, and during menstruation, this number changes. Allergies, parasite infections, collagen illnesses, and spleen and central nervous system disease cause it to rise. They're uncommon in the blood, but they're common in the mucous membranes of the respiratory, digestive, and urinary systems. They specialize on parasite illnesses. In allergic reactions, eosinophils are the most common inflammatory cells. Allergies such as asthma, hay fever, and hives, as well as parasite infections, are the most common causes of eosinophilia. They release chemicals that kill huge parasites like hookworms and tapeworms that are too large for phagocytization by a single white blood cell. Their nuclei are bi-lobed in general. A slender string links the lobes together. With eosin staining, the cytoplasm is packed of granules that take on a characteristic pink-orange tint. Basophil. Basophils are primarily responsible for allergy and antigen responses, as they release the chemical histamine, which causes blood vessels to dilate. They are challenging to research since they are the rarest of the white blood cells, less than 0.5% of total count, and share physicochemical features with other blood cells. Several coarse, dark violet granules give them a blue tinge, making them easily identifiable. The nucleus is bi- or tri-lobed, but due to the large number of granular granules that cover it, histamine and heparin are two substances excreted by them that boost the body's defenses. Histamine causes blood vessels to dilate and blood flow to wounded tissue to increase. It also increases the permeability of blood arteries, allowing neutrophils and clotting proteins to more easily enter connective tissue. Heparin is an anticoagulant that prevents blood from clotting and encourages white blood cells to enter a wound. Eosinophils and neutrophils are attracted to infection sites by chemical signals released by basophils. Monocyte. Monocytes, the most common form of white blood cell, have the same vacuum cleaner phagocytosis function as neutrophils, but they live considerably longer because they have an additional job. They present pathogen fragments to T lymphocytes so that they can be detected and killed. An antibody response is elicited as a result of this action. Monocytes eventually leave the bloodstream and transform into tissue macrophages, which clean up dead cells and fight microbes. This is a small part of what I can say in our discussion of white blood cells. Hopefully, this information will help you gain a better understanding of white blood cells. See you in another discussion. Don't forget to subscribe and leave your comments, guys.